Hi all, welcome to my YouTube channel, Know About Embedded System. In today's video, we're going to understand one of the important topic that's called as a PWM. So you might be knowing PWM stands for pulse width modulation. What is the use of pulse width modulation? So best example I'll give you pulse width modulation, motor control. If you want to control the speed of the motor, it is possible through pulse width modulation. If you want to control the light intensity of your headlamp, if you consider your vehicles, if you want to control the different types of illuminations, light intensities are possible. So that is done by this pulse width modulation. Like that, there are a number of applications are there that we will discuss in the video. If you are a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video. Pulse width modulation. What do you mean by pulse width modulation? The name itself says that pulse width modulation, nothing but you're going to modulate the pulse. So input to the PWM, so this is my PWM circuit. Input to the PWM circuit is your input pulse and output will be your modulated output. And so this modulated output is controlled by duty cycle. So pulse width modulation, modulated signal is generated by a control circuit which is going to generate the PWM signal. So how you can see here the pulse width modulation. So pulse width modulation is nothing but it's a technique where the width of the pulse will be modulated. How do you generate? So by keeping frequency constant, you just try to understand the word here, by keeping frequency constant. So we have to keep frequency constant. Then how do you generate a PWM? So it can be generated by controlling something called as duty cycle. In our PWM, there is something called as duty cycle that I'll explain in the next slide. We have to control the duty cycle, nothing but on period. When you consider any pulse, we will have two things. One is the on period and one is the off period. This is what you're seeing. So we have to control on period. By controlling the on period, in turn, it is going to control the duty cycle, nothing but this circuit. This circuit is responsible for controlling the duty cycle. And with the help of the controlling this duty cycle, we can generate PWM signal. Okay, so how it is possible that we will see with one example. Yeah, here you can see this is your different scenarios of PWM signal. Here, this is a 20% duty cycle. So this is a 20% duty cycle. This is 40% duty cycle. Here you can see in 20% we will get less output. Average output will be less. In 40% it is moderate, 60% it is okay. In 80% we will get maximum and 90% we will get maximum output. So ultimately, when you vary the duty cycle, the output average voltage will be controlled. How? That I'll tell you in the next slide. So how the PWM works? As I told you already, PWM input will be your train of pulse. This is what you are seeing. So three inputs were required. Three inputs were required. One is a pulse train of pulse, nothing but input pulse. The second one is controlling unit, where we will control the duty cycle of your pulse width modulation, and in turn that will control the average power of your PWM signal, and that will generate a PWM. Very simple in design. Input and duty cycle control. These two are very important to generate the PWM signal. So what do you mean by duty cycle? So when we say duty cycle, it's on time, controlling the on time of your pulse. You know that already. We will have a pulse. This already I have explained in the previous slide. So we have to control this on period. So to represent a duration of on time, we use concept called as duty cycle, and it is simple term to control the on period of your pulse is called as duty cycle. To define the duty cycle, we have a simple formula here. Duty cycle is equal to on time divided by total time period into 100. This is how we are going to calculate duty cycle. T on is nothing but duration of the signal in the on state, and total period is equal to T on plus T off. Here you can see this is T off and this is T on. So totally T is equal to period is equal to T on plus T off. Then we have one more important thing we have to understand, that is called average voltage. So this is also duty cycle and average voltage is playing a very important role in a PWM. Average voltage is equal to duty cycle divided by 100 into Vmax. This is a simple formula to calculate average voltage. Vmax is nothing but maximum output voltage. I have two use cases here. One use case with a duty cycle 20% and one use case duty cycle with 85%. Let us see with the 20% here. Keep 20% duty cycle and keep maximum value as output voltage as 5 volts. Then if we calculate average voltage for this 20%, I'll get output average voltage as 1 volt. This is with respect to 20% duty cycle. Same thing if you consider with respect to 85% duty cycle, the second use case, you will get output average voltage as 4.85. So this is the advantage. So how we can control the speed of motor, how we can control the light intensity, like these two are use cases. In case of 20% duty cycle, average voltage is 1 volt, but in case of 85%, average voltage is 4.25. So you just compare both the things, how we can control the output speed or output devices. Not only motor, not only light intensity, there are different applications are there. Using PWM, we can use ADC. In the ADC also we will use. Okay, so with the help of a duty cycle, we can control the output voltage, output average voltage. In turn, that will control the output device. Okay, so next one. So we have in our PWM, we have three types of PWM signals are there. One is called single edge and one is called double edge and one is called in single edge again it is classified into falling edge and rising edge that we will see one by one. So what do you mean by single edge? Single edge PWM. Single edge PWM means we can able to control any one of the edge. So first two whatever you are seeing these two are the examples for single edge. So single edge means you can see the arrow here. The PWM signal can be controlled either on a falling edge or on the rising edge. The first one and second one, whatever you're seeing, these two are single edge PWM. Here we are controlling pulse width either on a rising edge or on a falling edge. This type of circuits are called as single edge PWM. If the pulse is controlled on a falling edge, then that is called as a falling edge PWM. This is also called as left aligned PWM. Here you can see this is aligned towards left, that's why it is called left aligned PWM. And then if you compare the second example here, the rising edge, we are controlling PWM on a rising edge. This type of PWM outputs are called as rising edge. It is also called as right aligned PWM. If the pulse is aligned in the left side and controlled on a falling edge, it's called as a left aligned. And if you are controlling pulse on a rising edge and it is aligned towards the right side, then that is called as rising edge, or it's also called as right aligned PWM. Okay, so these two are examples for your rising edge and falling edge PWM under single edge control PWM. Then we have something called as double edge PWM. So double edge PWM, third example you see here, in the double edge PWM, observe here the pulse is positioned in the middle of total time period. Okay, observe here in the case of rising and falling edge, the pulse is positioned either in the starting or on the ending of your total time period. This is a total time period. So this is a total time period of your pulse. Okay, pulse width modulation. And if you compare the same thing with the double edge PWM, the double edge PWM is positioned in the middle of your total time period. That means it can be controlled either on a rising and falling both we can control. That type of PWM signals are called as double edge PWM. So these are all two types majorly, single and double edge. One is rising and one is falling. These two are under single edge, and double edge we will be controlling both rising and falling. Okay, I hope this is clear. So what are the applications of PWM? So application everywhere we will use. So we will use in motor control, LED brightness, headlamp control, audio amplifier, battery charging, voltage regulation, ADCs. Even I have not included here. In ADCs and DAC also we will use PWM. In robotics to control the servo motors. In inverters we will use. In automotive industry we will use throttle and fuel injection to control the automotive vehicles. Like this, wide applications are there with respect to the PWM. So PWM also plays a very important role in the embedded system. Okay. So with this, I just want to end my video. Before ending my video, I have one question here. So what is the difference between single edge and double edge PWM? So what is the difference between single edge and double edge PWM? Please write your answer in the comment section, and so write your opinion about this topic. Okay. So with this, I want to end my video here. If you feel this video is informative, please click on like button and subscribe my YouTube channel, Know About Embedded System.